Hi students, in this PowerPoint presentation we are going to get phase control rectifiers. So rectifier is a power electronic converter which converts fixed AC to variable AC. So in this lecture we are going to introduction to phase control rectifiers, classification of rectifiers, and single phase off wave rectifier with resistive load. So we are going to discuss three outcomes in detail. So before that, what is rectifier? So rectifier converts fixed AC voltage into pulsating DC voltage. So here the input is a fixed AC and the output is DC voltage. It is a pulsating DC. So phase control rectifier means used to convert constant AC voltage to variable. Usually SCRs are the power semiconductor switches and phase control rectifiers. So by changing the firing instant, control over the output voltage can be achieved. This variation of firing instant is usually known as firing angle. So this is by varying this firing angle we can control the operation of rectifiers. So based on supply, they are classified into single phase and three phase rectifiers. And based on the controllability, they are uncontrolled rectifiers, fully controlled rectifiers, and semi-controlled or half-controlled rectifier. So fully controlled means all thyristors, uncontrolled means all diodes. So coming to applications, they are used in the paper mills, printing presses, high voltage direct current transmission system, traction, and UPS. And for electroplating applications also where DC required, we are going to use rectifiers. So this is the circuit diagram of rectifier. So we are giving the sinusoidal supply, that is Vs equal Vm sin omega t. So the thyristor will be used and there will be R load. So the current flowing through load is I naught and voltage appearing across the load is V naught. So SCR in forward black during positive half cycle of the supply voltage. So in the SCR, when SCR is turned on, the load is connected to source and current flows from SCR to load. So when the SCR is off state, there is no connection between source and loads. So here we some modes of operation is there. When firing angle is vary from 0 to alpha, omega t equal 0, positive half cycle, the SCR is going to forward blacking mode. In the mode 2, when alpha is firing angle changes from alpha to phi, the trigger pulse is given at omega to alpha, SCR go to forward on state. So then the thyristor voltage is 0, V0 equal Vs and I0 Vs by R. Mode 3, when pi to pi, the alpha is varying. So then it is going to reverse blacking mode. So hence there is VT is appeared and Vs is 0 and is is also 0. This is the input sinusoidal waveform. So we are giving the pulses at some firing angle. So at the instead we are going to get this type of output waveform. So calculations, average value of a load output will be given by total time period and Vs dt. So that is Vm sin omega t dt. By solving this, the output voltage is Vm by 2 pi 1 plus cos alpha. So for single phase, the average value of output delta is Vm by pi 1 plus cos alpha. Coming to RMS value, that is root mean square value. It is updated by square root mean squaring the average output voltage, that is given by Vm by 2 root pi pi minus alpha plus 1 by 2 sin 2 alpha under root. So Vm is the maximum value of voltage. Output of DC power giver guy, V average equal V average into I average. Form factor equal RMS value of to ratio of RMS value to average value. Output S power is VMRMS into IRMS. Triple factor is form factor minus 1. Displacement factor is cos pi. Harmonic factor is IS1 dash by IS1. So coming to reflections part, we need to derive the equation for average value of the load output voltage, that is Vm by 2 pi 1 plus cos alpha. And coming to reflections part 2, so we need to derive the equation for RMS value of the output voltage. So which is the root mean square value for the average load voltage. So by solving this integration with respect to 0 to 2 pi, we get Vm by 2 root 2 pi under root of pi minus alpha plus sin 2 alpha by By this formula we get RMS value. Coming to lecture level practice questions, you have to know what is a rectifier and what is phase control technique, and also classification of rectifier based on single phase and three phase, and based on controllability of tau. You have to know. Okay, thank you.